Welcome students, and I am Ravi Shankar. Today in this class we are going to study about some of the problems that are being already asked in the competitive examinations like Neet, IIT, etc. And the first problem that we are going to see today is, see, an electron of mass me, which is initially at rest, moves through a certain distance in a uniform electrical field in a time of t1 seconds. Then after that, instead of electron, a proton is considered. A proton of mass mp, which is also initially at rest, but takes a time t2 to move through an equal distance in the same uniform electrical field. Neglecting the effect of gravity, the ratio of T2 divided by T1 is nearly equal to. So they have considered two particles. One of the particle is taken to be electron. So let us go for the solution. So one of the particle, they have considered it as electron. If you are taking the particle as the electron, let us take the mass of the electron as me. Then electrical field is considered to be same for both the cases. So let us take capital E as the electrical field. Initially, it is at rest. If it is initially at rest, we can say the initial velocity u equal to 0. What it is asked, see, neglecting the gravity, the ratio, time is being given. When an electron is moving through a certain distance in a uniform electrical field, you calculate what is the distance moved. See, we know that S is equal to ut plus half into at square. Since it is moving with, it is initially at rest, this u becomes 0 means this term will become 0. Let us consider what is the distance made or the displacement made. The displacement made, let us consider it as S for the electron is equal to half into, what is acceleration? Acceleration is nothing but E into E divided by M into, what is the time taken? Let us consider the time taken for the electron as T1 square. See how you know that the electron is considered, acceleration is considered to be E into E by M. The force experienced on the electron is given by E into E. As we know, force is mass into acceleration. We can get the value for acceleration is equal to E into E divided by M. So taking this and substituting it here, I have calculated the displacement that was being produced on that electron is given by half into E into E divided by M into T1 square. Take this as equation number 1. Similarly, you consider the proton. Let us take like this. Let MP be the mass of proton. MP be the mass of proton. If that is the case, then the acceleration produced on the proton is equal to, we can say E into E divided by, A is the applied electrical field, small e, charge of the proton divided by, instead of M, you will have put it as MP. If you want to write, you can write here as me, mass of the electron, and let us take this as mass of the proton. Here also, the initial velocity u equal to 0. Therefore, the displacement produced in case of the proton is, we can write it out as half into E into E divided by mass of proton into time taken. Let us consider it as T2. So T2 square. Let us take this as equation number 2. See, it was given, they move through an equal distance. Since the distances are equal, since it was given that the distances are equal, we can equate equation 1 and equation 2. That is, the distance covered by the electron is equal to the distance covered by the proton. Distance covered by the electron is half into E into E divided by me into T1 square is equal to half into E into E divided by m into T2 square. See, simplify this, you will be getting it as this half and this half will get cancelled. This E into E and this E into E will also get cancelled. So I can get the answer as, see, when I am writing, we are asked to calculate T2 by T1. So I am writing it like this: T2 square divided by T1 square is equal to, take this mass of proton to the other side, you will be getting mass of proton divided by mass of electron. Therefore, on taking square root, I will be able to get the answer as T2 by T1 is equal to root of, okay, square root of mass of the proton divided by mass of the electron. If so, what is the option? The option is taken to be option 3. So option 3 is the answer. So option 3 is the answer. So we can say the answer is taken to be what? The answer is taken to be option 3. Hope you should have understood this concept. So this is the ratio between what? Ratio between the two time intervals. Come on, now let us go with the second problem. Problem number 2. The magnitude of the electrical field required just to balance a drop of liquid in air of mass 2.4 into 10 power minus 4 kilogram, carrying a charge of what? Carrying a charge of 10 into 10 power minus 2 microcoulomb is dash. See, actually, we have to consider like this. You have to take two parallel plates. In one of the parallel plate, positive charges are being given, and in the another plate, negative charges given. So in between the two plates, you are having the electrical field, and let E, we are taking it out as the electrical field acting in between the two plates. In between the two, you are having the air medium. Here, the magnitude of electrical field is required. We have to calculate the electrical field. In order to balance, just balance a drop of liquid in air. So in this air medium, you are having a drop of liquid. So when you are having a drop of liquid, the drop of liquid is having a mass m, which is acting under the action of gravity. So it is pulled in the downward direction with m into g. Now, since this mass is having a charge q, the electrical field in between the two plates is made to act in such a way that the force acting on this is, it should be acting in the opposite side direction. So the force acting should be in the opposite side direction, means then the lower plate should have the positive charge, and the upper plate, the top plate should have what? The top plate should have the negative charge. Then only you can able to get the electrical field to be acting in the upward direction. If it is acting in the upward direction, then the electrical force is also acting in the upward direction. When the force due to electrical field and force due to the gravitational field are made equal, the liquid drop will be just in balance. So let us consider the solution. So in this case, we can say the liquid drop is just balanced, when the gravitational field or the gravitational force on the drop, when the gravitational force on the drop is equal to the electrical force developed. then the drop is said to be in equilibrium position, or it is just said to be just balanced. So let us write like this: force due to gravitational field as Fg and force due to electrical field as Fe. So we can write like this: force due to gravitational field, which we are considering it as Fg, is nothing but mass into gravity acting vertically downwards. Then we have to consider the force due to electrical field acting, which let us take it out as E into Q. It should be taken as Fe acting in the upward direction. In order to balance, in order to get balanced, in order to get balanced, the force due to the gravity is equal to force due to the electrical field. So force due to gravitational field is M into G is equal to force due to electrical field. I can say that it is E into Q. So simplify, what is the value of the electrical field now? The value of electrical field is M into G divided by Q. Substitute, what is the mass? The mass is given to be 2.4 into 10 power minus 4 kilogram. So 2.4 into 10 to the power of minus 4 kilogram. Multiplied it with gravity, you take the value as 10. That is G is equal to 10 meter per second square, divided by the charge Q. The charge Q is given to be 10 into 10 power minus 2 microcoulomb. So 10 into 10 power minus 2. In order to convert the microcoulomb to coulomb, let us put it out as 10 power minus 6. So on simplifying, you can get this 10 and this 10 will get cancelled. This 10 power minus 4 and this 10 power minus 6 get cancelled. If that is the case, you can able to get here as 10 power minus 2. So on simplifying, you will be getting it as 2.4 divided by what? Divided by 10 power minus 4, which we can say that electrical field E is equal to 2.4 into 10 power minus 4 Newton per coulomb or volt per meter, which is nearly equal to 2 into 10 power minus 4 Newton per coulomb. You can able to get this value as 2 into 10 power minus 4 if you are putting G is equal to 9.8 meter per second square instead of 10. For simpler calculations, I have taken the value of G as 10 meter per second square. So instead of 10, if you are putting 9.8 into 9.8 meter per second square, you can able to get the value nearly equal to 2 into 10 power minus 4 Newton per coulomb. So when you are taking the answer is the option 2 is taken to be your answer. Hope you should have understood this. So the electrical field, which is required to balance the oil drop in between or inside the electrical field, is considered to be 2 into 10 to the power of, sorry, not minus 4, isn't it? 10 power minus 4 taken to the numerator, it becomes plus 4. So we have to get it out as 2 into 10 to the power of plus 4. Here also it is taken to be plus 4 Newton per coulomb. Option 2 is considered to be the correct option. Okay, let us move on to the next problem, problem number 3. Come on, let us move on with the problem number 3. Two parallel metal plates having charges plus Q and minus Q face each other at a certain distance between them. If the plates are now dipped in kerosene oil tank, the electrical field between the plates will given us become 0, increases, decreases, and no change. You see, two parallel metal plates. Let us take like this, case 1. So in case 1, let us consider two parallel metal plates having the charges at one end, at the top plate, let us take at the top plate, you are having the positive charges and the total charge available is plus Q. When you are considering the bottom plate, let us take the bottom plate is having an total charge as minus Q. Initially, in between the two plates, you are having what? Initially, in between the two plates, you are having air medium. So if you are having air medium in between the two plates, then according to the application of the Gauss law, we know the electrical field in between two parallel plates of charges, in between the two parallel plates of charges is given by electrical field E is equal to sigma divided by epsilon 0, where sigma is equal to Q divided by A, that is surface charge density. Now, this is the case 1. What it is given? See, it was considered case 2. Let us consider the case 2. What it is given, you see, if the plates are now dipped in kerosene oil tank, then the electrical field between them is. So here we are having the two plates. At the top plate, you are having the positive charge and the total charge is plus Q. And at the bottom plate, you are having negative charge and the charge is considered to be minus Q. Now the two plates are placed inside the kerosene. So in between the two plates, the medium is now replaced from air to kerosene. See, when you are replacing the medium from air to kerosene, then automatically the permittivity becomes altered. The permittivity of kerosene, let us consider it as epsilon, which can be written as epsilon 0 into epsilon r. Here it is air. If it is air, then we can say permittivity as epsilon 0. So we got the expression for the electrical field when air is kept is given as electrical field E is equal to sigma by epsilon 0. If you want, we can write like this: electrical field in air medium. Now, when it is dipped inside the kerosene, the air medium is now replaced with what? Is replaced with the kerosene of permittivity epsilon having a dielectric constant as epsilon r. So automatically what will happen? See, what will happen means the electrical field in between, or the electrical field between the two plates is now equal to E of K Nuchkala, which is equal to E of K is equal to sigma divided by epsilon, but epsilon is equal to epsilon 0 into epsilon r. So I can write sigma divided by epsilon 0 into epsilon r. So I can write E of K equal to, see, you know this value, sigma by epsilon 0, already we have calculated as E0, or E of R divided by epsilon R, as epsilon R is always greater than 1. For air medium alone, epsilon R is equal to 1. For all other mediums, for all other dielectric mediums, epsilon R is greater than 1. So if kerosene is considered, if you are taking it as a conducting medium, it will become infinity. If you are taking it as, in general, if you are taking it as some other medium other than air, then we are saying epsilon r is greater than 1. As epsilon r is greater than 1, then we can say Ek, that is the electrical field in the dielectric medium is found to be less than that of the electrical, is found to be less than that of what? Is found to be less than that of the electrical field in the air medium. So we can say after introducing kerosene in between the two plates, the electrical field decreases. So we can say the electrical field decreases. So what is the option? So when you are taking the answer, in case this answer is option number 3. So option 3 is taken to be the answer. So in general, we can say if you are introducing a dielectric in between the two plates, then automatically we can say the electrical field will get decreased as epsilon r is always greater than that of 1. Electrical field and the dielectric constant are inversely proportional to each other. Hope you should have understood. Come on, let us move on to the next problem. That is the problem number 4. See, A and B are 2 points in an electric field. If the work done in carrying zero point 0.4 coulomb of electric charge from the point A to the point B is 16 joule, then you are asked to calculate the potential difference between A and B. So let us take like this. You are having what? You are having an electrical field. You are having an electrical field. So let us take the electrical field E is acting in this direction. Inside that electrical field, we have taken 2 points. One of the point is taken to be A and another point is taken to be B. See, it was given A and B are 2 points in the electrical field. If the work done in carrying zero point 0.4 coulomb of charge. So I am considering a charge Q, which is 0.4 coulomb taken from A to B. So the charge is moved from the point A to the point B. When the charge is moved from point A to point B, the work done is given by, let us take work done in moving the charge. Work done in moving the charge Q from A to B. Let us take that work done as W, which is given as what? Which is given as 16 joule. What it is asked, you are asked to calculate V, potential difference V, or you can say it out as dV, whatever may be. So how to calculate this? We can calculate it directly. See, as you know, the work done, let us take the solution here. See, we know that work done in moving a charge Q, from one point to another inside an electrical field is nothing but the potential energy epsilon, or you can say d epsilon, or the work done is equal to the potential difference dV multiplied with the charge moved. So I can say this work done W equal to dV into Q. So dV is equal to work done by the charge moved. Therefore, the change in potential difference dV is equal to what is this work done? Work done, it is given to be 16 joule divided by what is the amount of charge moved? It is 0.4. So I can write 160 divided by 4, multiplying numerator and denominator with the 10. I will be getting the potential difference between the 2 points as 40 volts. So we are getting dV is equal to 40 volts. So what is your answer then? Then your answer is considered to be, isn't it? Am I correct? 0.4 and the work done is 16.0. Okay, so 16 divided by, it is given as 0.4 or 4. Let us wait. Say I am getting the answer as 40 volt, but there is no 40 volt in this option. So we have to go with the problem again. And when I am going through the problem again, I am finding it out that the charge available is not 0.4 coulomb. The charge available is considered to be 4 coulomb. So if it is 0.4 coulomb, the answer will be equal to what? 40 volt. So if it is instead of 0.4, it is given as 4. See, I have written the problem in a wrong way. The problem given as instead of 0.4, they have given it out as what? They have given it out as 4 coulomb of charge. If it is 4 coulomb, here also I have to make a change. So here if I am taking instead of 0.4, if I am taking it as 4 coulomb, okay, here I have to consider it as 4 coulomb. Then here if it is 4 coulomb, then here also I have to change. Here I have to consider it as 4 coulomb. Then the simplification will also get a change, isn't it? So I am considering the simplification again. See, when I am taking the simplification again, see, the charge given Q is taken to be 4 coulomb. So the answer will be then 4 volt. So I can say the potential difference between the 2 points is taken to be what? Is taken to be 4 volt. If potential difference is 4 volt, then option is considered to be 3. So I can write the answer as option 3 as the answer. Hope you should have understood. So if you are taking instead of 4.4, you can get the answer as 40 volt. But the given problem, it is not given as 0.4, it is given as 4. So if it is given as 4 coulomb, then the answer is also considered to be 4 volt. Option C is, option 3 is considered to be the answer. Okay, let us move on to the next problem, problem number 5. Come on, now let us move on to the next problem, problem number 5. A positively charged particle of mass m kilogram and charge q coulomb travels from rest through a potential difference of V volt. What is its kinetic energy? See, whatever may be, energy is nothing but work done. What is the work done? Work done will be equal to the potential difference multiplied with that of the charge moved. Okay, let us consider the solution. So what is the solution? You see, a positively charged particle. So let us consider the charged particle as Q. Since it is given as positively charged, let us take plus Q is taken to be the charge of the particle of mass m. So it was given the mass of the charged particle as m. M kilogram and a charge q coulomb, okay, travels from rest. Initially, it is starting from rest through a potential difference of V volt. So let us consider capital V as the potential difference. You are asked to calculate the kinetic energy in Joule. So you are asked to calculate the kinetic energy. See, we know that in general, kinetic energy is given by the formula of into m into V square. But in the given formula, we are not having the result in terms of this V or this of or some other thing. So what I am calculating is, we know that in general, whether it is potential energy or kinetic energy, the energy is nothing but work done. Here, the kinetic energy is here. The kinetic energy on the charged particle Q is work done in moving the charge Q, work done in moving the charge Q by the potential difference V, by the potential difference V. Therefore, the kinetic energy is nothing but the work done, which is equal to the charge moved with the help of the potential. So the kinetic energy is given by the value Q into V. This is the answer. So when you are seeing the option, the option 1 is considered to be the answer. So I can say it out as answer as option what? Answer as option 1. So we have got the answer as Q into V, considering the kinetic energy as nothing but the work done. So in this case, since it is started from initially at rest and it is moving with the velocity v due to the acceleration, due to the work done by the electrical field, it was given as kinetic energy is equal to Q into capital V. Capital V, we are saying it as the potential difference produced by the electrical field in between the 2 points where the charges are being moved. Hope you should have understood. Let us move on to the next problem, problem number 6. Come on, go with the problem number 6. Two charges, 4 into 10 power minus 8 coulomb and minus 6 into 10 power minus 8 coulomb are at points A and B, respectively 50 centimeter apart. So let us draw the diagram for this. See, you are having 2 points. One of the point is taken to be A and another point is taken to be B. And the distance between the 2 points, let us consider it as D, which is equal to 50 centimeter. Okay, let us take like this, 50 centimeter. Now, the electric at point A, you are having a charge of, let us take that charge as Q1. And at point B, you are having a charge Q2. The electrical potential due to them is 0 on the line AB at a distance from AS. So I am considering a point P on the line joining A and B at a distance of X from A. And at this point P, I am taking it as the potential equal to 0. So I have to calculate what is the distance of P at which the potential becomes 0 due to the two charges. So we know that due to Q1, you can able to get a potential at P. So due to Q1, you are able to get a potential at P. Let us consider that potential as V1. Due to Q2, you are having a potential at P. Let us consider that potential as V2. According to the problem, the total potential at that point is equal to 0. So the total potential at that point is Vp, which is equal to 0 according to the problem. So I can write the potential at P as, okay, we can write like this. Potential at P, which is equal to Vp, is equal to sum of the two potentials at this point P due to Q1 and Q2. So potential at P due to the charge at A, that is V1, plus potential at P due to the charge at B, Q2, that is V2. But given us the potential at that point P is equal to 0. So I can write 0 equal to, what is V1? Potential is given by the formula 1 divided by 4 pi epsilon 0 into Q by R. Instead of Q, it is Q1. Instead of R, it is considered to be X. Plus again 1 divided by 4 pi epsilon 0 into Q2 divided by the remaining distance. What is this remaining distance? This remaining distance is d minus x. So I am writing this as d minus x. See, when I am considering Q1 and Q2, Q1 is given as positive. Q1 value of Q1 is in terms of positive value and Q2 in terms of negative. So I can write like this. Potential of a positive charge is positive potential and potential of a negative charge is negative potential. So I can write like this. 0 equal to 1 divided by 4 pi epsilon 0 into positive charge Q1 divided by X. Here, since the charge is negative, I am putting minus of 1 divided by 4 pi epsilon 0 into Q2 divided by d minus X, because the potential due to a negative charge is negative. So I am putting it as minus. Taking this to the other side, you can able to get it out as 1 divided by 4 pi epsilon 0 into Q2 divided by d minus x is equal to q1 divided by 4 pi epsilon 0 into q divided by x. On simplifying, this 1 by 4 pi epsilon 0 will get cancelled. Now you substitute what is the value of q2. The value of q2 is magnitude alone now. 6 into 10 to the power of minus 8 divided by d minus x is 50 minus x. I have taken, or I have placed the value of the distance in centimeter itself is equal to, then what is q1? Here it is nothing but here it is q1. And now you have to substitute what is q1. Q1 is 4 into 10 to the power of minus 8 divided by the distance is x. Now you simplify 10 power minus 8 and this 10 power minus 8 will get cancelled. Make a cross multiplication. You will be able to get 6x is equal to, here when you are multiplying, you will be getting 200 minus what? 200 minus 4x. Take this 4x to the right side. You will be able to get it out as 10x. 10x is equal to 200. Or I can write x is equal to what? X is equal to 200 divided by 10. So the value of x is equal to 20 centimeter. Therefore, we can write at a distance of, so we can write at a distance of 20 centimeter from A, the potential becomes 0. The potential will be what? The potential will be 0. So what is the answer then? Answer is option 2. So I can write the answer is option 2. So this is what we are taking or considering as the problem number 6. Okay, hope you should have understood. Let us move on to the next problem, the problem number 7. Come on, let us move on to problem number 7. See, what is that problem number 7? Two positive charges of magnitude 4 coulomb and 6 coulomb are placed 10 centimeter apart. The electric potential at a distance of 10 centimeter from the midpoint on the right bisector of the line joining the two charges is. See, we are having 2 points. Let us consider one of the point as A, where you are having, let us having A, where you are having a charge as 4 coulomb. Let us take it as Q1. And another point as B, where you are having the charge Q2, which is equal to 6 coulomb. So the distance in between the two is taken to be 10 centimeter. You are asked to calculate the electrical potential at a distance of 10 centimeter from the midpoint on the right bisector. See, when you are considering the midpoint, let this point C, or let us take this point O as its midpoint. Now, on this midpoint, from this midpoint, you consider what? You consider an right bisector. That is, you are taking a line like this. Okay, when you are considering a right bisector, let us take this point as C. At this point, you are asked to calculate what is the total potential. So if you want to calculate the total potential at point C, the point C will be experiencing two potentials, one due to Q1 and another one due to Q2. So when you are considering the point C, due to this plus 4 coulomb, you are having a potential at this, let it be V1. And due to this charge at B, you are having another potential, let it be V2. So the total potential V is equal to V1 plus V2. If you want to calculate the total potential at C, total potential at C is equal to V, which is potential at C due to the charge Q1 plus potential at C due to charge Q2. So the distance between the point A and point C, let us take it as R. Similarly, the distance between point B and point C, let us consider it as R. Both are same. The distance between O and C is again equal to 10 centimeter. So by applying the Pythagoras theorem, we can say R is equal to root of, isn't it? AC square is equal to OA square plus OC square. OA is 5 centimeter. So I can consider it as 5 square plus 10 square. So R will be then equal to root of 25 plus 100. You will be able to get it out as root of 125 meters. So when I am taking R is equal to root of 125 meters, I can take this value and substitute it here. What is the total potential V? Potential at C due to the first charge given by the formula 1 divided by 4 pi epsilon 0 into Q1 divided by R plus 1 divided by 4 pi epsilon 0 potential due to the second charge Q2 divided by R. So the total potential V, take this as a common, 1 divided by 4 pi epsilon 0 common, and also R can also be taken as the common, multiplied it with Q1 plus Q2. So simplify, we can write 1 by 4 pi epsilon 0 can be written as 9 into 10 to the power of 9 divided by R. R is root of 125. So root of 125. Then we can write this root of 125 into what are the charges? Q1 is considered to be 4 coulomb and the Q2 is considered to be what? Q2 is considered to be 6 coulomb. So you will be able to get it out as 9 into 10 to the power of 8 divided by root of 125. So on simplifying this, you will be able to get it out as you have to calculate what is the value of root 125. So when you are taking that root of 125, it is 11.18. Okay, let us put it out as 11.2. Here you are having 9 into 10 to the power of 8. On simplifying, I can able to write this like this: 90 divided by 11.2 into 10 to the power of what? 10 to the power of now 10. Okay, I am writing 90 divided by 11.2 into 10 to the power of 8. Sorry, 10 to the power of 7. On simplifying, I am getting the answer as 8 into 10 to the power of 11 volt. So you just check the answer. So just I have given it in approximate manner. So simplify and get the answer, and you will be getting the answer as 8 into 10 to the power of 11 volts. So this is taken to be the potential. So if this is the answer, then the option that you can able to get it out is option number 3. So please check the answer by doing the simplification. Okay, hope you should have understood this, and the answer is 8 into 10 to the power of 11 volts. Let us move on to the next problem, problem number 8. See, let us move on to the next problem, problem number 8. 4 point charges minus q, minus small q, then plus 2 small q, and another one 2 capital Q are placed one at each corner of a square. The relation between capital Q and small q, for which the potential at the center of the square is dash. So first of all, let us consider what? First of all, let us consider a square. Okay, you consider this as a square. So the 4 corners are having the charges. One is minus q, another one is minus small q, another one is plus 2 small q, and another one is plus 2q. You are asked to get the relationship between small q and capital Q. The given condition is the electrical potential at the center V equal to 0. Electrical potential at the center means it is the intersection of what? Intersection of the diagonals. So when you are considering the intersection of the diagonals, at the intersection of the diagonals, that is at the center point O, you are having four potentials. The sum of the four potential is 0. So we can say the total potential at O. Let us consider the total potential at the center point O is equal to 0, which is the sum of the four potentials. 1 due to minus q, let us consider it as V1. 1 due to minus small q, let us consider it as V2. 1 due to plus 2q, let us consider it as V3. And 1, let us consider it as plus 2q. For that, let us take it as V4. When you are considering the potential, in general, potential is given by the formula 1 divided by 4 pi epsilon 0 into q by r. Here r is equal to the distance from any one of the corner to the center. If you are taking the side as A, then the distance between the corner to the center is A by root 2. Whatever may be the distance between the corner to the center, the distance is A by root 2. So if it is A by root 2, then R I can consider it as A divided by root 2. Now, to apply the concept, so the total potential V equal to V1. V1 is 1 divided by 4 pi epsilon 0 into the charge available is minus Q divided by R. What is R? R is A divided by root 2. Similarly, plus the next one, 1 divided by 4 pi epsilon 0 minus Q divided by A by root 2 plus 1 divided by 4 pi epsilon 0 into then 2 into small q divided by A by root 2 plus 1 divided by 4 pi epsilon 0 into 2 capital Q divided by A divided by root 2. Isn't it? Now you simplify this. How you can simplify? 0 equal to, because sum of all these potential is 0. So 0 equal to, now I am taking the capital Q to one side and small q to other one. See, when I am considering this, I can write like this. I am grouping 1 divided by 4 pi epsilon 0. I am taking it as common. So taking this, I can write it out as 2q divided by A by root 2 minus q divided by A by root 2. Then plus the remaining 2. 1 divided by 4 pi epsilon 0 into, when I am taking these two, I am taking 2q divided by A by root 2 minus q divided by A by root 2. Now on simplification, I can able to get it out as 0 equal to 1 divided by 4 pi epsilon 0. This A by root 2 can also be taken out. That can be written as root 2 divided by A. Then I can get 2q minus q. So I will be getting it as q. Plus here also 1 divided by 4 pi epsilon 0 into, when this A by root 2 is taken out, I can write A by root 2. So I can write root 2 by A into 2q minus q. Again, I will be able to get it out as q. Isn't it? Now, here I can take one to the other side. I am taking one of the value to the other side. So what I can do, I am taking this to the other side means 1 divided by 4 pi epsilon 0 root 2 divided by A into q equal to, when I am taking the second term to the other side, minus of 1 divided by 4 pi epsilon 0 into root 2 divided by A into small q. Now simplify this 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 will get cancelled. Root 2 by A root 2 by a will get cancelled. So the relation is capital Q is equal to minus of small q. So I got the relationship between capital Q and small q and got the relation as capital Q is equal to minus q. So answer is option A. So answer is, we can consider the answer as option A or option 1 is the given answer. Hope you should have understood this. So simplify in a regular manner, you can able to get the answer easily. Okay. So let us see the remaining in the next class. Thank you.